Hi, welcome back to LeetCode. So in this video, I'm going to discuss LeetCode problem 3532 path existence queries in a graph 1. So you are given an integer n representing the number of nodes in a graph. So the level are from 0 to n minus 1. So n is equal to 3 means there are 3 nodes. One is 0, another is 1, another is 2. Okay, so you are also given an integer array nums of length n sorted in non-decreasing order, an integer max diff. So an undirected edge exists between nodes I and j if the absolute difference between nums of I and nums of j is at most max diff. Okay, so if the absolute difference between nums of I and nums of j if less than equal to max diff, then there is an edge between I and j. Okay, so this is undirected, so I can go I to j and also I can come back from j to I. And so you are also given a 2D integer array queries. For each queries I, we actually have ui and vi. We have determined that whether there exists a path between nodes ui and vi. So suppose we actually have some graph, undirected graph. Suppose this is the graph. Okay, graph is look like this. So suppose labeled as 0, 1, 2, 3, 4. Now we want to know that is there any path exists between 0 and 4. So that means if we start from 0, can actually we will know that I can actually reach 4 or not. So you can see that from 0 to 2, then 2 to 4, I can reach 4. So I have to return true. Okay, else if it's not possible to reach the destination, then you have to return true and false. Okay, so for this example one, so we actually have n is equal to 2. So that means we actually have two nodes, one is 0, another is 1, and we actually have nums array that actually 1 and 3. So and max diff is 1. So we have two nodes, one is 0, another is 1. So first of all, we have to know that is there any edge possible for 0 between 0 and 1. So what do you have to do? What is the absolute difference between 0 and 1? So 3 minus 1, absolute difference is 2, that is greater than 1. So there is no edge between 0 and 1. Okay, so I have checked all the possible edge, means 0 between 0 and 1 or 1 and 0 both are actually same. Okay, now we have actually queries array. So in queries, first queries is 0 comma 0, means we have to check that is it there is can actually reach from, if we start from 0, can actually reach 0 or not. So this actually within the like whatever the source and both are destination, both are same, so we return true. So that's why first answer is true. Next query is 0 comma 1. So we have to see that if I start from 0, can I actually reach 1 or not. So if I start from 0, can I actually reach, there is no outside edge, edge from 0. So that's why we will return false, because there is no outside edge from 0. So that's why we will return false. Got it? So what is the brute force approach we can actually think? So first of all, we will check all possible actually edge possible or not, means between 0 and 1 we will check, then 0 and 2. In this actually I will check 0 to n minus 1. Okay, similarly for I will check from is there any edge possible between 1 and 0. Similarly for 1 and 1, then 1 and 2. In this actually I will check with 1 and n minus 1. In this for each pair I will check there is there any possible edge or not. Correct. So what will time study for this to check edge? So if there is v, what is n number of nodes, so I will check for each node, with each node, other edge node. So that will be n into n, because you can see that first I will checking with 0, then checking with the 0, 1, 0 and 2, 0 and 3. In this is 0 to n minus 1. So that's why for 0 I will run n times. For 1 I will run n times. In this I will, for n minus 1 I will again run n times. So that's why time should be n into n, correct, n square, to generate the edges. Now what will do, I'll get the queries, I'll iterate the queries array. Now I will get one u, another v. So I will check that, I will call dfs start from u. I will see that is it in any path, am I is there any path to reach v. So whenever I will reach v, so return from here true. Okay, else I have to iterate all the possible path, then if I not able to reach v, then I return ultimately false. Correct. Clear? So what time actually for this? So I am actually, if there are q number of queries, correct, q number of queries, q. So for each query, what I have to do, I will start from u and I will try to explore all the possible path and then say that which node actually possible, because this is undirected. That means in worst case, I will traverse all the nodes, enter a graph, n nodes. So that's why in each case, in the worst case, what will happen, for each query I will visit n nodes. So that's why the time actually q into n, correct. So total time wasted will be, this is clear, the brute force approach. Total first I will, this is for create the edges, then I will actually for q into n. So this is for each query I will visit n nodes. So that's why q into n. Now here actually n value is 10 to the 5 number of nodes, so that will be 10 to the power 10, so it will give us a TLE, correct. So this brute force approach will not work. Now how to optimize this? Now you can think that, so ultimately what I have to do, I am generating a graph, correct. In this way I am, suppose this is actually the graph, undirected graph. Now ultimately what, suppose this is 0, suppose 1 2 3 4. So what I have to do, I am actually calling what DFS, I am starting from suppose 1, suppose. So I am exploring all the possible path, then I'm checking that am I possible, is it possible to reach destination or not. So how can you optimize this? How you can think about that? That means if I somehow know that in constant time, if I somehow know that whatever that you can think that 3 is present in some group, 1 is also present, node 1 is also present in the same group, node 0 also present in the same group. So someone know that what is the group number or ultimately parent of this node 3, that will be the ultimate, if both the parent of the, you can think out of the disjoint set. So if two node u and v, parent of ultimately both u and v, parent of both u and v is actually same, that means what, it is connected, same group. So if suppose in this 0, parent of 0 is 1 and parent of ultimate 3 is 1, that means what, if both the parent is same, that means I can reach from 0 to 3, 3 to 0, because this is undirected graph, correct. So that's why I'll check that what is the group, okay. That will help us to, in constant time, I actually identify that this is actually within the same group or not. If it is within the same group, that is clear that I can actually reach from u to v or v to u, because it is an undirected graph. Now this is clear that we only need to know the group number, correct. Now one thing actually you can think, you can actually see that suppose they mention that our nums array is sorted, correct, 1 2 3 4 5. Now our max diff allowed is 1, suppose. So this is actually ultimately node 0, node 1, node 2, node 3, node 4. So 0 and 1, between 0 and 1 age is possible, because the difference is 2 minus 1 1, that is less than equal to 1, correct. So this is possible. Now 0 and 2 node is possible, so absolute difference will be 3 minus 1, it is 2, that is actually greater than 1. So no edge is possible between 0 and 2. Then you can just think about that, is it possible to have any node between edge between 0 and 3? No. Why? Because whatever the nums value is present in the 0, node 0, that is actually constant in the left side, but node 2 value and node 3 value is actually increasing. They mention this is actually sorted non-decreasing order, that means this will be at least same, whatever the value which is present in the node 0, node 2, that will be same, at least same in the node 3 also, otherwise it will be greater than the previous value, means the node 2, that means it will be always increasing. Whatever the previous value between 0 and 2, the diff of whatever the diff of 2, that will be all, diff of 3 will be always greater than equals to diff 2, correct. So there should not be any have any edge between 0 and 3, similarly for 0 and 4 also, correct. This is clear logically. So how actually you can think about that? Now you can think on, let one example more, that will be more clear. So suppose we actually have 1 2 4, suppose then 5, suppose 10, okay, and maximum diff actually allowed is 2, okay. So this is node 0, node 1, node 2, node 3. So first we'll check that with 0 and 1. So absolute difference value is 2 minus 1, it is actually 1, okay. So this is less than equal to the max diff. So we actually have 0 and 1 is connected, correct. 0 and 1 is connected. Now 0 and 2, 0 and 2, the difference is 4 minus 1, 3, that is greater than 2. So they are not connected, there is no edge between 0 and 2, okay. But if I check between 1 and 2, difference will be 4 minus 2, it is 2, that is less than equal to 2. So there is an edge between 1 and 2 is connected. Now ultimately you can say that 0 and 2 is connected also via 1, because what to do, first I will jump from 0 to 1, then 1 to 2. So what actually we are checking ultimately, we have to check only the adjacent, that if these two are connected or not. If these are not connected, suppose 1 and 2 is not connected, node 0 and node 1 is not connected, so this is a different group, this is a different group. So is it possible to connect node 2 in node 0? No, correct, because difference will be more. 0 and 1 is not possible to connect. How is it possible to connect 0 and 2? I have already explained, because the difference will be increased. Now I will check that is it possible to connect 1 and 2. If it is ultimately connected to 1 and 2, then ultimately I can suppose in this example also, what I have seen, I have seen that 0 and 1 is connected. Then ultimately we are seeing only node 2 and 1. Why? Because I know that if it is connected or not, it doesn't matter. If it is 1 is creating a new group, because something, the difference between node 0 and node 1 is greater than the max diff, then we can't create a edge. So that will be a different group. So we also, I have also ensure that node 2 will be also create a new group. There will be no edge between 0 and 2. So I will check only the adjacent nodes only. Whatever the I and I plus 1, I will check that is there any edge possible or not. If it is, there is an edge possible, that means I and I plus 1 in the same group, correct. And also I minus 1, I have already checked with I. If it is create a new group, suppose I have assigned 0 is present in group 0 something, 1 is created a group 1, but 2 if it is the absolute difference between 1 and 2 is less than the max diff, so it will present in the same group, correct. Now I've created this, suppose for this example, let's take this example number 2. So this example, so 2 5 6 8, so I will see only this, I have already assigned this, that 0 is present in group 0. So I will see that this node 1 is it part of the previous group or not. So how will check that? So I'll check what is the difference between 2 and 5, means node 0 and node 1. So 3, so that is greater than 2, so this will be create a new group, correct. Now I will compare with 5 and 6, means node 2 is a part of the previous group or not. So I'll see that what is the difference between 5 and 6, this is 1, so less than equal to 2, so this will be the same group, it will be 1. Next is 8 and 6, so this is a difference is 2, less than equal to 2 max diff, so it will be part of the same group. So you can here you can see that 0 is a different group, this node 1, 2 and 3, these are actually same group, means I can reach 1 to 3, 1 to 2, 2 to 1, 2 to 3 any node, because this is undirected. So that's why we have to know that what is the group, in which group this actually present, correct. So how do I assign that? I will see that first I will assign that group 0, node 0 is present in the group 0, okay. Then I will say that node 1 can actually possible to present this node 1 into the previous group. I have to check only the difference of the adjacent, and I have already explained why I am not checking the difference between node 2 and 6, node 0 and node 2, because it is already handled by this previous node 1, node 0 and node 1. If node 0 and node 1 is connected, that means, and also node 1 is connected to node 2, that ultimately we can say that node 0 and node 2 is ultimately connected, so don't need to check that, correct. means 0 and 1 is connected. Then we are saying that 1 and 2 is connected. That means what? Ultimately 0 and 1 and 2 connected. If 0 and 1 is not connected, okay, and 1 and 2 is connected, that also ensures that there is no connection between 0 and 2 also. This is sure because this is non-decreasing nums. So if any doubt, any suggestion, is a comment on that. Now go to the code. So I have to know what is the ultimately group number. So parent of that. So I have assigned by default 0 for group for node 0 it will be 0, and I'm start from the node 1, and group will be 0. Previous group is 0. Okay, group number 0, and I'm starting from node 1. I'll run up to go up to n minus 1. So for each current number node I and node I minus 1. So if the difference between that nums of I and nums of I minus 1, if it is greater than the max diff, so that means this current node cannot be part of the previous group. So I will create a new group. So I will increase the group number by 1, group 1, new group. So then I will assign this what is the parent of the current node, what is the group number. Means if it is the same group, means the difference is less than equal to max diff, that means this will be the part of the previous group. So I will actually assign that time group will be the same, correct, else it will be increased by 1. Now we have to return a vector of boolean. So that means true or false for each query. So for each query I will check that whatever the u actually present and whatever the v actually present in each query, I will check that u and v in the same group or not. If it is same group, that means I can reach any in any one path, at least one path that should be present because it is undirected. So that's why I will check that parents of current u or I0 if equal to the parent of I1 means v, that means this is a part of the same group. So I'll store true, else I'll store false. What? And ultimately after completing of each query, I will return the answer vector. What? So in this case, in this approach, what is the time study for this? So you can see that this for loop will run big of n times if there are n nodes, and this for loop will run queries, number of queries time q, and there is no nested for loop, so this will be also big of q. So ultimately the time study will be big of n plus q, n plus q. So this is linear time study big of n ultimately. So this actually obviously it will give us the optimal approach, and it will also pass. Okay, and I've shared this code in the description, you can check that. Also if you are not yet subscribed, please subscribe channel. Thank you.